Welcome to this tutorial on calculating the probability of default PD using PySpark. In this video, we will talk through how to set up a simple PySpark project and implement a PD formula and a sample created data. The probability of default is an essential risk measure in finance, estimating the likelihood that a borrower will default on a loan. Using PySpark, we can efficiently process and analyze data at scale. Let's dive in. The formula we will post calculate PD or probability of default is A and B here. In this example, set to 0.5 and 0.3 that influence the sensitivity of the probability based on balance and monthly income. This logistic function models PD as a probability between 0 and 1, where a higher balance and monthly income combination generally result in a higher PD, indicating higher credit risk. Our example simulates a basic scenario with the 3 borrowers and their credit data, balance and monthly income. We will calculate each borrower's probability of default PD based on their balance and monthly income. Okay, let's start the code. First, import necessary modules from PySpark. And now install the frac session. We start by importing a Spark session and expression from PySpark, which we will use to create a Spark session and perform calculations. The Spark session allows us to process data in a distributed manner, ideal for large data set. And okay. Now sample data for credit data. This sample data contain 3 columns: ID, balance, and monthly income. And now define the schema for data frame. And now create data frame. This section set up or sample data with the columns ID, balance, and monthly income. The data includes 3 sample records with the different financial profiles. We then convert this data into a PySpark data frame, making it easier to perform operations like transformations and aggregations. And next step, add PD column using the provided expression. In this line, we use with column to add a new column, PD, which is store the probability of default for each row, and the formula here calculates PD using the logistic function. The formula align with the logistic model for probability. This means for each row, the model estimates PD based on the balance and monthly income. A higher product of balance and monthly income in this context will push the PD closer to 1, indicating higher risk. And finally, show results. Okay, finally we display the data frame with the calculated PD values. This allows us to verify the calculated PDs for each browsers. In this tutorial, we calculate the probability of default for sample created data using PySpark in Databricks based on the distributed capabilities. The logistic function we use is commonly employed in credit risk modeling to determine likelihood of a browser defaulting. With PySpark, we can extend these methods to much larger data set, enabling efficient risk analysis at a scale. Thank you for watching, and don't forget to like, share, and subscribe if you find this video helpful. Bye.